Okay, we're recording now. So here in the Moodle, I've added on the Python code, I've added two Jupyter Notebooks files, 5.1, 5.2, and I've added a text file that we'll use for today called Wikipedia Fruit. And then I've pushed these to, let's see. I pushed these to GitHub as well. So in GitHub, you should be able to see the same files, 5.1, 2, and 3. And if you pull those to your desktop, GitHub desktop, you should have these new files appear, 5.1, 2, and 3. So again, 5.1 and 5.2 are both Jupyter Notebooks files, and then 5.3 is a text file, txt suffix. So today, we'll spend about an hour on 5.1 and 5.2, and then we'll probably spend about 20 minutes on the exercises from the homework from yesterday, and then about 40 minutes on 5.1, 5.2, and then for the remaining 30 minutes, I'll upload a skills test, which you can take for the last 30 minutes. So first of all, let's start with yesterday's homework. So going back over the for loops. So yesterday we were looking at for loops. We were combining if statements and for statements, or if statements with while statements. We had nested repetition, so we had for loops inside of for loops, and we also talked about list comprehensions. So with the for loops, we were looking at for loops on lists and dictionaries. We looked at for loops on strings. We used the range function. We used if in for loops to change the vowel. Would you like a smoothie or an smoothie? We use if in a while loop, popping each item out and adding it to a count. We use the break statement. Okay, and then here with the for loops, we produce pairs of fruits, for example. And then with comprehensions, we reproduce the same list using a basic list comprehension, and then we also use list comprehensions with if conditions. So for example, fruit, here's a list of fruits I dislike, and for the fruit in the list of fruits, if it's not in the list that of fruits I dislike, then include it, otherwise I don't. And then we also adapted it. Here, let me just, we're going to need these functions anyways. Here's our produce basket going down here. So these are fruits. Our list comprehension adds a smoothie for each fruit in the list of fruits. We take that item and then we concatenate the string smoothie, and that returns a list with each of our fruits concatenated with the string smoothie. So orange smoothie, pear smoothie, banana smoothie. And then for the if condition, we have a list of fruits I dislike, kiwi and apple. And here, as long as the fruit is not in the list of fruits I dislike, then we're going to return it in this new list called fruits I like. And that will just return orange, pear, banana, removing the fruits I don't like, kiwi and apple. And then we can do the same thing, fruit smoothies I like. We have the conditional statement of fruits, as long as fruit is not in fruits I dislike. we'll take that item and we'll concatenate smoothie. So now these are fruit smoothies I like. We didn't, I introduced a formula for dictionary comprehensions without conditional statement and with the conditional statement. These are just for your reference, but we didn't have time to cover them yesterday. So in the homework, we have for exercise 0, instead of a list comprehension, use for and if to create smoothies I like. So here's the original code. And this created fruit smoothies I like. The list comprehension is one way to do this, right? It takes the place, or it kind of combines for and if statements. Does anybody have code for exercise 0 doing this without a list comprehension? Still using for and if, but not using the list comprehension structure here. If you have that, you can upload it. If not, I'll just type it out real fast. Okay, that's fine. So, so for this, basically, you're going to take the same pieces of this comprehension. The for loop is here, right? For E in fruits. The conditional statement is if E not in fruits I dislike. Right. And then we can print E smoothie. So that will return those items. But if we want to create a list, then instead of printing them, we could create a list, an empty list, fruit smoothies I like, empty list, and then instead of printing, or as we print, we can append this. So that'll still print out the list, but it'll also, if we check fruit smoothies I like, that should also output the same list that we had before, right? So here, this is a very common, I use this all the time when I'm coding. You create an empty list, you run a for loop, you have some kind of conditional statement, and then you append some item to your list, having adapted it or changed it somehow. So that's exercise. So this list comprehension is useful for loops with simple conditions and simple, one-line statements here. But if the manipulation here for these items in the list gets complicated, if you have to do more than one or two things, the list comprehension is too simple for that. And in that case, you'd need, you might want to run like several lines of code here, which you couldn't really fit that in the list comprehension very elegantly. So list comprehensions are kind of a quick, like a very quick and convenient way when you're just manipulating list items in very simple ways. But if you're doing it in a complicated way, then it's better to just use the for loop with the if statement and then just, type out all your code here as much as you need. Okay, so that's that. Okay, so exercise 1, your fruit basket contains 2 bananas, 1 apple, 1 kiwi, 1 pear, and 1. Ooh. Danya was waiting for this one. So here's Danya's solution. We have fruits, banana, apple, kiwi, pear, banana, orange. Right. So 2 bananas, 1 apple, 1 kiwi, 1 pear, 1 orange. Okay. Write code that could produce the above sentence. Fruit's length. Fruit length is this. Fruit list your fruit basket contains. Okay, so we're getting the stem of the sentence there. And then for I in range fruit's length. Okay, so remember range function has to have two variables. So it'll probably be from 0 to fruit's length, right? This will cover the index. If we're going to index like this, we're going to go from the 0 item to this fruit's length. And then for item in fruit's I, fruit's amount equals the count. Okay. If the fruit amount is greater than 1, apostrophe is S, else apostrophe. Great. So here I like to just, we can define it here. Okay, that's fine. And then I like to define this up above because sometimes Python is not always picky about this, but other computer languages are. Like if you first define a variable inside of a conditional statement, it'll say, you know, we don't recognize that variable. So I like to define the variable first, and then we can get rid of the if statement, and then apostrophe is defined as this, and then in the event that fruit amount is greater than 1, we can change it to S. Otherwise, it just stays like that. Okay, if item not in fruit list, then okay, this is getting hairy. Okay, fruit list. So if I run this, no, let's just run this and see what happens. Okay, your fruit basket contains 2 bananas, 1 apple, 1 kiwi, 1 pear, and 1 orange. Perfect. So that's great. Okay. There could be multiple examples out there, but this is fantastic. So, and he's using, Daniel is using the statement here to see if we've come to the end of the list, right? And if we haven't come to the end of the list, then we're going to add a comma. And if we are at the end of the list, then we're going to add this and then a period. So this is a great solution. Right. So exercise 2. Whew, this is this was asking a lot, so I didn't know if let's see. I'm happy to see. I know Danya did this exercise. Did anybody else do this one as well? If anybody else had a solution for this? Yeah, go ahead. So here I gave you fruit prices. You already had the fruit basket, the list of fruits. And so using the number of fruit in each basket and the type of fruit and the fruit prices, you could calculate a receipt if we were purchasing these. So, and the receipt would have each fruit, how many were purchased, what's the unit price, what's the subtotal for each fruit. That would all go on like one line, and then the subtotal for all the fruit, and then a line beneath this showing the sales tax. And I mean, this is Okay, so let's go with that. Let's try Salia's code here. Okay. So okay. Oh, interesting. Okay, so you like specified your own purchase. That's cool. Um, okay. So here, let's see. So we're printing out the sales tax. We're printing out, here's the total. You're saying the total is 0, but then you're going to add the total as we go along. That's great. For each item in the purchase, so we're going to purchase 3 oranges and 5 kiwis. We have, we're going through each item in the purchase. So we have an orange, 3 oranges, the price is 0.55, and the subtotal is this, which Talia got by multiplying. Where do we multiply? Okay, here's the purchase item. That's how many we're buying, and here's the price, the unit price, and then the subtotal. Oh, you calculate the subtotal here. Great. Perfect. Thank you. Okay, and then you add the subtotal to the total. That's fantastic. So here, if we wanted to, we could round this. I think we can use round. We may have to use, let's see if this works. Oh, so if we round it, that rounds it to the nearest integer, but let's round to, I think if we do round with 2 decimal points, that'll give us a, great, it'll give us like $1 and change. And then kiwi, perfect. And then if you wanted to space these out a little bit, so you've got quantity here, you could just put a tab in front of each of these, and that might help to kind of space things out a little bit. Let's see, here's let's just put some tabs in there and see what happens. So you can start, that's okay. That's all right. Great. And you could put in like another tab if you wanted to kind of line these all up. So yeah, anyways, you can start doing this, and this looks fantastic. This has everything, the quantity, the price, the subtotal, and the total overall, the sales tax. Here for sales tax, we wanted to, the only thing is with sales tax, we wanted sales tax to be
calculated. Yeah.
Or let's see here, total, I guess. Sales tax times the total, right? So if the total is the subtotal here, if the subtotal is $5.40, then we want then the sales tax should be 0.1 times that, right? And then this should be, okay, you have the net of tax here is total. I see. So did you add these? So let's do, we've got this total here, which is actually our subtotal, right? And then you've got the sales tax times that, and then we could just have the total. We can just do times 1.1, and that should give us around that. And that should add the 5.4 plus the 0.54, and that's the total net of tax. So 5.94. Okay, great. This is, you guys did a great job on this. So yeah, sorry you couldn't upload the code. It might be a restriction in Zoom. So I added another exercise here to find a more elegant solution to this pop the first 4 fruits. I didn't do this. I added this afterwards because I was kind of dissatisfied with this example that I gave. So, but I'll leave this as an exercise for you guys to do later if you want. No, I'm really happy with this. That's fantastic. And I really liked, Sally, I really like that you added in this purchase, that you didn't just use this one, but you can create a separate dictionary, right? For every, so that's great. Very creative. Okay, so I'll upload this. I'll refresh the day 4 code later, so you have these solutions too if you want to go back and look at them. Okay, so moving on to today. Let's day 3. 5.1. Okay, so 5.1. So today we're going to talk briefly, just this is more kind of a nuts and bolts lecture about running Python on your system. I'll update this link after today's tutorial. So up until this point, we've talked about primitive data types, non-primitive data types, lists and dictionaries. We've talked about basic control structures, if, for, and while. We've talked more about control structures, combining if and for and while statements, nested repetition statements, list comprehensions. Today, we're going to talk about 3 ways to run Python on your computer. We're going to talk about input and output and operating systems and directories. So first of all, and then we'll have the skills test. So first of all, I want to introduce 3 ways to run Python on your system. So the first way is to run Python in shell, the Python shell in command prompt, if you have a PC, or terminal if you have a Mac. So to run the Python shell in command prompt, you just open your command prompt. Now, if you have a hard time finding your command prompt, I like to put it as a big icon here because I use it all the time. But it should be under, I always forget, it should be under Windows System, and there's command prompt, right? So, and then you can just right click and pin it to your start here if you want. So here's your command prompt, and to run the Python shell in command prompt, you just type Python. So you're in the command prompt now because you've got these 3 carets, and it says Python, and this tells you the version and some other things on Windows 32, whatever. So this is command line Python. So we can create fruits, apple, orange, kiwi. Oops. And so I made a mistake there. I forgot to include the quote. If you don't want to type everything out again, if you just push the up button, so you can't see this, but on my keyboard, I'm just pushing the up button, and that will return the most recent line that I wrote. So I'm just going to edit that. Now fruits is in there, right? And if I can run, for f in fruits, enter, and it knows that more is coming, right? But remember, so if I run print f here, it's going to give me an error because I didn't indent, right? So remember, for statements, for loops, you have to indent. So enter, and then I'll just push a space. That's enough. And then print f, and then it runs it, apple, orange, kiwi. So it looped through my fruits list there, and it printed out each one, right? And if I want to do a list, fruit smoothies, and do a list comprehension, right? This will be, so it's going to be for f in fruits, right? That's the for loop. But then in the beginning of this, I have to write my statement. So this will be f plus smoothies, right? So this is my list comprehension for f in fruits. Concatenate the string smoothies. So now if I do this, okay, so it's in there. You can use this command prompt. You can use the Python shell to do this, but it's not really convenient to code a script, right? Because you'll want to like save it as a script and run it all at once, or it's hard to edit, you know, and go back and rerun things. So usually I only use a shell when I just want to test out, like, you know, for example, like, oh, how do I, you know, how do I pop like an item, and, you know, was that the right way to do it, and see what's left. You know, I just use it to test like one line at a time or something. So I rarely use shell. It's not very convenient for coding longer scripts. And then also I mentioned in here, to exit the Python shell, there's an exit function, right? So you'll run exit with the two curved brackets. So I'll exit, and now I'm back out in my Windows command prompt. So that's how you get into shell and get out of it. There might be a lot of other shortcuts and ways to use it, but I just don't use it enough to memorize those. Okay, the second way you can run Python. So the third way here is Jupyter Notebook, but the more common way when you're just coding is to write a Python script. To write a Python script in editor, and then run in command prompt or in any server, whatever. So how am I going to create using? So first I'm going to use an editor to create and save a Python file. I like to use an editor that knows Python syntax so that it can color my code as I write. So, you know, you could write Python here. Like this, and save this. You know, you could save this code as a, where am I going to save this? Oops, sorry. I'll just save it to my desktop for now. So I could save this as script1.py instead of a txt. I have to save it as a .py, right? So now it's script1, and you can see it here on my desktop, right? This is that file. So here, then if I go to my command prompt and I go to my desktop, here's script1 right here. So to run that, I can just do py script1.py, and it ran that script, right? But this Notepad is not a very good text editor for Python because it's naive about the Python language. So my favorite editor in Windows is Notepad++, which, despite the similarity in the name, is a completely different program. So Notepad++ can do, it recognizes Python, but it also recognizes all of these other languages. So it's a fantastic text editor. It recognizes Java, JavaScript, JSON, you know, it recognizes R, Ruby. So it's a very powerful text editor. Unfortunately, it is not supported in Mac. So for Mac, you have to find another, but there are all kinds of text editors out there. So here you just code fruits equals this. Now, you can see I haven't saved this yet. Once I save it, let me save this to my desktop again. I'm going to save it as script2 and .py. Once I do that, once Notebook++ knows that this is a .py file, a Python file, now it's going to apply the coloring. It's going to color the, right? So it colors strings like lighter. These reserved words like for, in, print, these are reserved words in Python. It'll highlight those for you. So it makes it easier, and it knows, okay, this is all indented, so we're in a for loop here, right? So anyways, then you save it, right? So it's saved here, script2, right here. Now if I go back out to my command prompt, right, -w, I can see there's script2 right there. So I can run py space and then the name of the file, script2 py, and if I run it, right, it's gonna print apple and banana. It's just gonna run it, right? So what if I create fruit smoothies here, a list comprehension. Okay, so here I create a list comprehension off of fruits. So what's going to happen if I run this just like this? I'm going to run this again. I saved the script2, and I'm going to run it here. What's it going to return?
It won't print anything.
Yeah, it's not going to return anything because I didn't ask for any output, right? It is creating this list, right? But it just ran it. It did it, but I'm not asking it to print anything. So I can print out fruit smoothies here. Okay, so now what's going to happen? See, it did it again, but the difference is command prompt, you printing or running a script, a Python script, is not the same as Jupyter Notebooks. So when you just write the variable here, that is not, command prompt doesn't read this as like printing. So if you actually want to output, if you actually want to print through the command prompt what's in this, you need to use the print function. So we can run it again, right? And now it'll print it out. So, but the command prompt does not interpret, you know, just the variable statements like this as like you wanting to print them out, right? Unlike Jupyter Notebooks, where in Jupyter Notebooks, right, if I write, sorry, in Jupyter Notebook, if I write fruit, you know, Jupyter Notebooks knows I want to output fruit, right? So that's one difference in terms of printing or output. But usually I'm not, well, I'll print some things out to the screen, but usually I'm, you know, taking data from a file, like processing it and saving it to another file or something like that. So output to the screen is usually not my primary goal when I'm running a script. But anyways, this is the second way, and this is actually the most common way. So you write a Python script in an editor and then run the file in command prompt. So that's the second way. Okay, the third way is obviously to write your code in a Jupyter Notebook or some kind of, you know, kind of markup editor like this. So you can write your code like this. And you can, of course, you can run it in Jupyter Notebook, and that's the end of the story. Or if you want, you can download the notebook as a PY script and run it in command prompt. So here, all of this stuff is markup language. The only code on this page are these 3 lines, right? Or these 3 cells. So, but you can still download as, and let's download it as a .py file. And now I'm going to save this to my desktop as well. I'm going to call it script 3. And I'm going to put that, it knows it's a py file, so I'm just going to call it script 3. Okay, so now if I look at desktop, here's script 3. Let's open it up and see what it actually looks like in a text editor. So I'm going to open it up in Notepad++. Now this looks a lot more, so the active code here, all of this is markup, right? And so when I download it as a Python file, it's all gonna be hashtags and comments, right? Because none of this is actually Python script, not active Python script. So the only active script here are those 3 lines at the bottom where I define the list fruit, I output fruit, and then I have this, I output this, right? So, but that's fine. I can still run this. It was script 3, right? So I'll run that. And I still, orange, apple, kiwi. This doesn't do anything in command prompt. And then for item in fruit, print item, right? So, so you can convert your Jupyter Notebook code to Python script. The only caution I would give for that is, when you're dealing with a very long script like this, you might have stuff in there that you don't want. You may not want it to run that script in that order. Maybe you just did some things to check it out, or maybe you changed some variables and you forgot to change them again when you changed something here, and then you went up and you played it with it, and then you went down and you changed something. So you just have to be careful with with Jupyter Notebook, because it's very easy to change, variables at the bottom and then go change variables at the top and then forget that you've changed them when you go back down to the bottom. So Python scripts, when you're running this in command prompt, it's just going to run the script from the top to the bottom, all, boom, 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 boom. And if there are any errors, for example, here, let's introduce an error, right? Just FRUI, that's nothing. Right, it's gonna, the name FRUI is not defined, and you notice it didn't print orange, apple, kiwi because it discovered this error before it hit this line, right? So when command prompt is running your Python script, it's going to run it line by line. If it succeeds, it'll move to the next line. If it doesn't succeed, if it pops in, if it produces an error, it's just going to exit your code. It's just going to stop right there. We don't recognize that. We can't continue reading the script, and it'll never get to this lower thing, right? And so it just we ran that script, and then it returned this error and stopped, right? So if we just delete that, right, and then run it again, right, and now it prints out orange, apple, kiwi. So that's all I want to say about this. Shell, marginally useful. The most common way is to write your script and then run it in command prompt for a server. More and more, I'm using Jupyter Notebook to write my code, and then once I have my code kind of all cleaned up, exactly how I want it, then I'll download it as a script, and then if I don't need to like manipulate it back. So 3 options for that. Okay, so now I'm moving on to 5.2, running Python on your system. Okay. 5.2. All right, so we talked about 3 ways to run Python. Okay, now input and output. So we haven't talked about libraries yet, but to do input output, you will need to import the IO library. So here's a few notes about libraries. The IO library is included with the base installation of Python, but when you're sometimes we'll use libraries like pandas that are not included in the base installation. In that case, you need to install that library using pip. This is one way to install. So you would just, in your command line, you would type pip install and then the name of the library. You might have already done this when you install Jupyter Notebook or Jupyter Labs, right? Like pip install notebook or pip install Jupyter Labs. If you get an error when you run pip, which is very common when you first install Python, here's a link to help you debug that. So let's look at the functions in the IO library. This is a library which helps us so here's the IO library. These are core tools for working with strings. You have over here text IO, binary IO, and raw IO. Most of the time, especially in data science, we're just working with text. So text IO, text input IO means input output. So inputting and outputting, the easiest way to create a text string is with the file open. You create the file name here. You can specify an encoding. I usually work in UTF-8, and then there are these codes here that we'll talk about. So here's binary and here's raw, but we don't usually deal with those. So for text encoding, let's see. We're mostly going to use the open function here. And and we'll use the close function when we're done with the file. We'll also use the read lines function. And I also wanted to share the may not be in this file. It is somewhere else. Yeah. No. Okay, so okay, so when we're reading in a text, here are a few tutorials for file handling and for opening files in these W3 schools tutorials, which are helpful. I created a text file called Wikipedia Fruit. All I did was go to Wikipedia, search for fruit, and I just copied this text down to here, and I saved it in a text file, in a TXT file. So this file is available here, Wikipedia Fruit. So if you open this up, it's the text file that I copied, right? So that's all it is. It's the text from Wikipedia entry on fruit. So now, actually, I changed the file name, so I'm going to need to change this file name. Okay, so the file name is Python 101, day 5.3, Wikipedia fruit.txt. I'm just saving this as a string, right? So it's just a string called file name. And now I'm going to use the open function and file name. And I'm going to save that to file. So this open function is going to take this string and it's going to open it as a file. Okay, now if I run file, what is file? File is a text IO wrapper, whatever this is. the name of it is this. The mode is R. I didn't write that here, but it's as if I've done this. So that's the default, which means read. So and this is the encoding, which is not UTF-8, but it's something else. So this mode R means I can only read the file. I can't write to this file. So I can use this function called readable to see if this is a file that I can read. Yes, I can. I can use length function here. Length on this particular object is an error. This object does not have a length function. So I'm going to use the file and this function called readLines, and I'm going to, what readLines does is it takes all of the text in this file. Oops. In this file, it takes all the text and it saves it to a list where each line is a string. So I'm going to save that as file text. And now I'm done with file. So I'm going to close it. So it's closing your file buffer. It's customary to close the file buffer after you're done using it. But sometimes I forget to do it, and Python will automatically close this file buffer when your script ends, but it's better if you close it as soon as you're done with it. So I'm closing the file, so I can't access it anymore, but I already saved everything I need to file text. So what is file text? It's a list where every line in this text is saved as a string. So this has all the text of the file of Wikipedia Fruits saved as a list of strings. So the type of file text is list. Now I can look at the length of file text, right? There are 361 strings in this file. Right? So if you go down here to this Wikipedia Fruit, you can see that it also has 361 lines of text. Each of those lines is saved as one string in this list. So it's very easy to process now. If I do file text 0, that's going to return the first line, right? File text 0, 5, I'm just indexing on a list. So it's going to return the first 5 lines of text, 0, 1, 2, 3, 4. So the fifth line apparently is empty, right? So fruit from Wikipedia, jump to navigation, further uses, blank. So, right, these are saved here, the first, second, third, fourth, fifth. This \n is just the carriage return that gives us the next line. So, okay, what can I do with this? So I'm going to create a variable called apple count. I want to count how many times in this text, how many times in this Wikipedia article on fruit do they mention the word apple? It's in the picture here. How many times is the word apple in this? So if I search here, I get 19 instances. Let's see. Apple with a space, only 5 instances. Space with apple, I get 10 instances. Space with a space, I only get 3. I'm getting weird, counts here, but so I'm going to set the variable equal to apple count equal to 0. And then for each line in file text, so I'm going to loop through every line in of these 361 lines. And if apple is contained in that line, I'm going to update apple count by 1. Right? And then when that's done, I'm going to report in Wikipedia's article on fruit, apple count contains lines. Let's see. Wikipedia's article on fruit, however many lines contain the word apple. So I'm going to run this, and I get 16 lines contain the word apple. One reason why, if I run apple here, why I get 19 in this count, but I only get 16 here, is because, can anybody think of why I didn't get 19 here, why I only got 16?
Maybe some lines contain more than one.
Yeah, that's right. So if I want, so I could do, let's see. If apple is contained in the line, could I do a line count apple? Would that change it? Yeah, so if I do, instead of just appending it, if apple's contained in the line, I can just add the line, I can just update with line count, right? And in fact, in that case, I don't think I even need the if statement, right? So I could just do this for each line in file text. I'm going to add the number of times apple is included in that line, and that should also just give me 19, right? That's a more elegant answer. So so this, let's see, so Wikipedia's article on fruit contains X references to apples. "19 references to apples." Okay, so now what if I wanted to process those sentences, process every sentence where the word apple was, where the word apple appeared. So in this case, I am going to need the if condition here. So apple count is here, and apple lines is going to be an empty list. And I'm going to go through every line of these 361 lines. And if apple is contained in the line, then I will update apple count like this, same way. But I will also add the line, that particular line, to this list of apple lines, right? And so So if I run this, then Wikipedia's article on fruit contains 19 references to apples in 19 lines of text. Let's do that. Where here apple count is counting all the instances of apple, but length of apple lines is only counting the number of lines. It's counting the number of lines where apple appears. So it contains 19 references to apples in 16 lines of text. And then here, for each line in apple lines, I'm printing it out. So these are the lines where apples have been mentioned, right? And then maybe I wanted to process these somehow. So I'm actually using code very similar to this right now to process information about politicians in South Korea and Taiwan. And I'm using Wikipedia pages where I'm trying to look for references to family members, references to corruption or election scandals, references to their educational background. So I'm using very similar code. I'm kind of looking for certain keywords in the Wikipedia text. If that keyword appears, I'm extracting the sentence, and then I'm going to further process that sentence to figure out, like, you know, if a university is mentioned, did they actually attend that university, or is it some other reference, like, or if it's a scandal, like what was the nature of the scandal, or if it was a family member, like is it their brother, their father, their mother, right? So this is kind of a first step in like text processing and kind of in data mining, for example. That's why I'm showing you this example. Okay, we can also write text. So here's a tutorial on that. The only difference is we're still going to use the open function, but instead of the R parameter, we're going to add a W here that means to write a new file. So and I'm going to create a new file called file out. This file doesn't exist right now, Apple lines. So I'll run this. File out is a text.io wrapper with this name and the mode W, which means we can write. If I try to read the lines, I can't read lines because this is an outgoing file. Right? It's not supported for this. So, but we can start writing. Instead, we can write, use the write function on file out. So I'm going to write a list of lines containing Apple, and I'm going to add a couple of carriage returns to put some spaces. So I'm going to write that, and I'm going to close it. And now if we go to here, we can see Apple lines. It's in the same directory. So I'm going to open this up, and Apple lines contains list of lines containing Apple and 2 carriage returns. That's what I wrote there. And now I'm going to reopen this file. So if you use this letter W, it's going to write a new file. So it's going to purge whatever was in this file, and it's going to rewrite this file or write this file from scratch, right? But say we already have a file like this, and we just want to add lines to it. We want to append text to this buffer file. We don't want to like completely start from scratch. In that case, you use the A mode here for append to append text to a new file. So we'll open up the same file, but with the A parameter. We'll call it file out again. And then to recall our list of Apple lines here, the first 3 lines, right? I want to write the lines from Apple lines to the file. So I'm going to run this. Okay, so for a line in Apple lines, so I'm not taking all the lines from the Wikipedia text. Now I'm just taking those lines from the 16 lines we found in Apple lines. And for each of those lines, I'm going to write those lines plus a carriage return to give us space to this file, and then I'm going to close it. So let's do that and close it. And now if we go in here, I want to reload it. Now all of these lines have been in here, added in here. I added a carriage space just so you could see the spacing between them. But if I was doing data processing, I wouldn't actually include these spaces between lines. So, and these are there should be 16 of them, but I've spaced them out by 2, so that's why they're 33 lines. Okay, so these are all the sentences I extracted from the Wikipedia page that include the word Apple. We should be able to find Apple 20 matches, 19 because, and then this 20th that I included up here. Right? So we have those 19 instances of Apple. All right. So it's 12 o'clock. I just want to give you a couple of quick notes about operating system and directories. So here are 3 other useful libraries: OS for operating system, sys for system and date time. So here's a tutorial for operating system. You can import OS. OS get CWD gets your current working directory. So if you run this, you can see on my computer, my current working directory is users, Sol, Dropbox, technical, GitHub, KIMEP Data Science, right? And that's where that's this path here where I'm running this file right now. So that's my current working directory. And that's also why when I save this, when I open this file Apple lines, it saved it right here because it's going to save it in the same working directory as wherever I'm running my code. Right? If I wanted to save it in a different folder, I would have had to put, you know, some additional, I would have had to change the path here. You can, so we can save this path. I'm going to save this string as a path tutorial. And now, okay, so I can look at I can use list dir to get the files in my current directory. If I run that, I get all these files. Those it's a list, it gives a list of strings, which are the file names. These are exactly the files in this folder, right? I can get, here's another path, GitHub, right? So this is the path to the parent directory. If I go up one to GitHub, here's my parent directory, right? So, and the path for that is this, right? So if I save that as a string, this is the parent directory. Now I can list the directory of that path, not the current working directory, but of the files in this, and that's going to give me, I didn't find it yet. Okay, and that, so these are the folders or files in this directory, right? It gives me those. So, but my working directory is here. I can change my directory from this current directory to GitHub, which is path GitHub. And if I do that, now my working directory will be here, right? And now if I try to open, let's say I try to open this Apple text, right? Let's do it. So somehow it still knows my, oh, because, sorry. Okay, so my current working directory is now this GitHub folder here, right? This folder does not have the file Apple lines. So if I try, if this is my current working directory and I try to open this file, it should give me an error saying no such file or directory, right? Because Apple lines is not in this working directory. So, right, I don't see Apple lines in there. So if I want to access this file, I'd have to go back to the working directory. I'm going to change my directory. I saved my path here, GitHub. Sorry, my original tutorial directory. I could change that. And now I'm back in KIMEP Data Science, Python 101. And now if I open this, now it doesn't throw an error, right? Because I'm in the proper directory. So there it is. So I just wanted to show you, these are some of the tools you have, OS and sys. There are a couple other tools here that I don't use very often, but you can check like your system, you can check the paths that are saved in your system variables, the date time library is very useful for printing out like the current date and time, which your system, that's how you can access those from your system. So these are some other useful libraries for running Python on your particular system. So that's everything I wanted to share with you about that today. So I'll upload this and the YouTube video of this up to the Moodle and to the GitHub. Now for the skills test. So I'm going to upload the skills test. Here's the skills test. Just so you know, you'll have 30 minutes to take it. There are 5 shorter exercises, which are worth 5 points each. There are 5 longer exercises, which are worth 20 points each. That's a total of 125 points. To pass, you need 60%. So you need 75 out of 125 points. So, you know, that means if you only finish like 3 of those longer exercises, you'll still get a passing grade, right? So as long as you can finish, you know, like all the shorter exercises, and how many would you need? You need like 3 longer exercises, then you'll get a passing grade. So you may not have time to finish all 5 longer exercises. If you do, like, that's great. So I've kind of created it like that, so you don't have to, so you can kind of pick and choose which of these longer exercises you want. So I don't expect you to finish all 10 questions, because some of the longer exercises are a little bit tricky, or not tricky, but they might take you more than, you know, 5 or 10 minutes each, 5 minutes each. So here are the exercises. I will upload this now. Here to GitHub. Let's see here. What did I do? Okay. So I'm pushing that to GitHub right now, and I will also upload to Moodle. I should have just added this up earlier. Yeah, so while you guys are working on this, so I'm creating the assignment right here. So this is the Python 101 skills test. I'm attaching the file here. So download this file and run it on Jupyter Notebook. When you have completed the test, please upload it here in Moodle. And then I will allow submission types of file submission. So so you should be able to so you should download it, and then when you're done, you can just update it. Upload it here. Okay, so it's 12:11 right now. Please, I'm going to stop sharing my screen now. Let me stop the recording as well. I think that's enough for the tutorial.